This is the complete rapid-fire run-through for the AI Risk Manager interview. 25 questions across the whole role with a straight, strong answer for each in about 35 minutes. We're organized into 5 sections: fundamentals and governance, risk assessment and life cycle, bias, fairness and Gen AI, security and third party, and monitoring, incident and leadership. 5 questions each. Same rules as always. Every answer leads with a one-line takeaway in bold, those are your anchors, and each has a say this soundbite you can repeat almost word for word. And keep the risk manager's lens on everything. You own the response, you design controls, set appetite, and make the accept or mitigate call. You're an enabler with guardrails, not a blocker. Let's run the 25. Fundamentals and governance. Questions 1, 5. Question 1. How is AI risk different from traditional software or IT risk? One-line answer. AI risk is probabilistic, data-driven, and emergent. The system can behave unpredictably, degrade silently as data shifts, and cause harm at scale. So you manage it across the whole life cycle, not just at release. Back it up. Traditional software is deterministic. AI is probabilistic. The data is part of the system, so bias and drift are first-class risks. Harms scale fast and silently, and risk is continuous, designed through monitoring. Say this: traditional IT risk is about the code doing what it was told. AI risk is about a system that learns, drifts, and can be wrong at scale. Question 2. How would you align an organization with the NIST-AI risk management framework? One-line answer. Operationalize its 4 functions. Govern as the backbone. Then map, measure, manage as a continuous loop anchored to a real system, with govern setting policy, roles, and appetite across the other 3. Back it up. Govern sets policy, accountability, risk appetite. Map establishes context and catalogs risks. Measure assesses with metrics, bias, drift, robustness. Manage prioritizes, mitigates, monitors, and feeds signals back into map. Say this: I anchor on govern as the backbone, then run map, measure, manage as a continuous loop around a real system. Question 3. How do you set AI risk appetite for an organization? One-line answer. Translate the board's tolerance into concrete, measurable thresholds per use case by impact, autonomy, and reversibility, so teams know what's allowed without escalation and what isn't. Back it up. Appetite is a business decision you enable, not invent alone. Make it concrete with thresholds. Differentiate by use case and tie it to escalation, self-approve versus sign-off. Say this: appetite is only useful if it's concrete, a threshold a team can act on without asking, and a clear line for when they must escalate. Question 4. Where does AI risk management sit in the 3 lines of defense? One-line answer. Risk management is the second line. You set the AI policy, frameworks, and appetite, and oversee the first line that builds AI, while staying distinct from the third line, audit, that independently assures it all. Back it up. First line builds and owns the day-to-day risk. Second line sets policy and monitors. Third line audits independently. Your job is oversight and enablement, not building or auditing. Say this: as second line, I set the guardrails and oversee the builders. I don't build the models, and I don't provide the independent assurance audit does. Question 5. How would you prepare a high-risk system for the EU AI Act? One-line answer. Classify first, then stand up the high-risk obligations as live controls. A risk management system, data governance, technical documentation, human oversight, logging, and the conformity assessment, owned with clear accountability. Back it up. Confirm the tier. Obligations flow from it. Stand up the risk management and data governance controls. Make documentation, logging, and human oversight real and owned. Drive the conformity assessment and keep it current. Say this: first confirm it's high risk, then I make each annex obligation a living, owned control, not a one-time compliance document. Risk assessment and life cycle. Questions 6, 10. Question 6. Walk me through how you'd run an AI risk assessment on a new model. One-line answer. A structured pass. Understand the use case and context, identify risks across data, model, and deployment, score them by impact and likelihood, then assign owned mitigations and a monitoring plan. Back it up. Understand the use case and who's affected. Identify risks across the life cycle. Score by impact and likelihood, weighting scale and reversibility. Assign owned mitigations and monitoring. Say this. I assess across the whole life cycle, data, model, deployment, then turn each material risk into an owned mitigation with monitoring. Question 7. You found 30 AI risks. How do you prioritize what to act on? One-line answer. Rank by risk, impact times likelihood, weighted for scale, harm, and reversibility. Then act on the critical few first. Don't treat every risk as equal, or you'll dilute effort and lose leadership. Back it up. Score consistently with the AI multipliers. Surface the critical few. Match effort to risk. Accept, mitigate, transfer, or avoid. Tie priorities to appetite so the cut line is defensible. Say this. I force a priority order against risk appetite. Leadership needs the 3 that matter now, not 30 that all say hi. Question 8. How do you manage the data risks behind a model? One-line answer. Treat data as a controlled asset. Govern its sourcing, quality, lineage, and lawful basis upfront, and monitor for drift after deployment, because most AI failures trace back to data, not the algorithm. Back it up. Govern sourcing and lawful basis before training. Control quality and lineage for traceability. Watch for bias entering through the data. Monitor for drift after launch. Say this. Most AI failures are data failures, so I govern sourcing, quality, and lineage upfront and monitor for drift after launch. Question 9. How do you decide whether to accept, mitigate, transfer, or avoid an AI risk? One-line answer. Match the treatment to the risk against appetite. Mitigate what you can cost-effectively reduce. Transfer what others bear better. Accept what's within appetite with sign-off, and avoid what can't be brought within tolerance. Back it up. Mitigate with controls where cost-effective. Transfer via contracts, insurance, vendor accountability. Accept with documentation and sign-off when residual risk is within appetite. Avoid when it can't be tolerated. Say this. Every risk gets one of 4 answers. Mitigate, transfer, accept, or avoid. Decided against appetite, with acceptance always signed off, never silent. Question 10. How do you embed risk management across the AI lifecycle? One-line answer. Put a risk gate at every stage. Design, data, build, validation, deployment, monitoring. So risk is managed continuously, and a model can't advance without meeting the prior gate's controls. Back it up. Design needs a risk assessment and approval. Build and validate needs independent validation. Deploy needs a go/no-go against appetite. Monitor needs live drift surveillance. Say this. Risk isn't a launch checkpoint. It's a gate at every lifecycle stage, and a model can't advance without clearing the one before. Bias, fairness, and Gen AI. Questions 11-15. Question 11. An HR screening model is found to have historical bias. What do you do? One-line answer. Contain, then fix at the root. Pause or add human review on high-stakes decisions. Diagnose where the bias enters, data, label, or objective. Choose a fairness metric fit to the harm, remediate, and monitor going forward. Back it up. Contain first with human oversight. Diagnose the source. Pick a fairness metric that fits the harm. They conflict, so it's a judgment call. Remediate and monitor continuously. Say this. First, I contain the harm with human review, then fix the root cause in the data or objective, and monitor fairness so it doesn't drift back. Question 12. How do you manage the risk of a black box model stakeholders can't understand? One line answer: match explainability to the decision stakes. Use interpretable models or explainability tools where decisions are high impact. Ensure human oversight and document the model so it can be challenged and defended. Back it up. Higher stakes demand more explainability. Use SHAP, LIME, or interpretable models where it matters. Keep human oversight on consequential decisions. Document for regulators and affected people. Say this: explainability should scale with stakes. The higher the impact on a person, the more I insist the decision can be explained and challenged. Question 13. What controls prevent sensitive corporate data leaking into public LLMs? One line answer: layered controls, an acceptable use policy, technical guardrails like DLP, or an approved enterprise gateway, data classification so people know what's off limits, and training, because the leak is usually a person pasting data, not a breach. Back it up. Policy for acceptable use, technical controls, DLP, egress, or a sanctioned LLM with no training terms. Classification so staff know what's sensitive, and training since most leaks are well-meaning employees. Say this: the leak is usually someone pasting data into a chatbot, so I combine policy, DLP, and an approved no training gateway with real user training. Question 14, a high frequency one. What are the top GenAI risks you'd manage and how? One line answer: anchor on the OWASP LLM top 10. Prompt injection, sensitive data disclosure, hallucination, excessive agency, and manage with defense in depth, input and output controls, least privilege on tools, human in the loop, and monitoring. Back it up. Prompt injection is number one and can't be patched, so layer defenses. Control what data reaches the model. Validate outputs before they drive decisions. Apply least privilege to the model's tools and actions. Say this: I anchor on the OWASP LLM top 10, and since prompt injection can't be patched, I manage GenAI risk with layered defenses, not one control. Question 15. How do you choose a fairness metric when they conflict? One line answer: there's no universally right metric. They're mathematically incompatible. So you choose by the harm, the context, and the law, document the trade-off, and own the decision rather than pretending one is correct. Back it up. Demographic parity, equalized odds, predictive parity can't all hold at once. Choose by the actual harm. Let legal standards constrain the choice. Document why this metric and what you traded away. Say this: you can be fair by one definition and unfair by another. So I pick by harm and law, then document the trade-off and own it. Security and third party. Questions 16-20. Question 16. How would you structure an AI red teaming exercise for a proprietary model? One line answer: scope it to realistic threats. Assemble a cross-functional team. Attack the model and the system around it. Prompt injection, jailbreaks, data extraction, abuse. Then feed findings into prioritized fixes and retesting. Back it up. Define scope and threat model. Mix security, ML, and domain skills with tools plus manual creativity. Attack the model and wrapper. Triage by risk, fix, and retest. Say this: I scope it to a real threat model, attack the model and the system around it, then turn findings into prioritized fixes and a retest. Question 17. What adversarial risks threaten a deployed model and how do you manage them? One line answer: manage the main attack classes: evasion, data poisoning, model extraction, and inversion, with input validation, training data integrity controls, rate limiting and access controls, and monitoring for abnormal query patterns. Back it up. Evasion needs robustness testing and input checks. Poisoning needs data integrity and provenance. Extraction and inversion need rate limits and access control. Monitor for abnormal query patterns. Say this: I map the attack classes: evasion, poisoning, extraction, inversion, and put a control against each, plus monitoring for abnormal queries. Question 18. How do you assess and govern a third-party AI vendor? One line answer: due diligence the vendor's model, data handling, and security upfront. Demand evidence like model cards, SOC2, and certifications. Lock risk controls into the contract. No training on your data, breach notice, right to audit, then monitor ongoing. Back it up. Diligence, model provenance, and security. Demand evidence, but no SOC2 covers security, not bias or performance. Contract for no training, retention, breach notice, audit rights. Monitor ongoing. Say this: I diligence the model and data handling, lock the risk controls into the contract, and keep monitoring. A SOC2 alone never covers the AI specific risk. Question 19. How do you handle shadow AI, the unsanctioned tools across the business? One line answer: reduce the driver, then surface and govern it. Make the sanctioned path easy. Discover shadow use via network and expense signals and surveys. Risk triage what you find and bring it into governance rather than just banning it. Back it up. People go around slow governance, so fix that first. Discover via logs, expenses, and surveys. Triage by data sensitivity and impact. Govern it in because bans drive it underground. Say this: shadow AI is a symptom of a slow approval path, so I make the sanction route easy, then discover and govern the rest rather than just banning it. Question 20. How do you manage the risk of building on a foundation model you don't control? One line answer: manage the layers you do control. Rely on the provider's evidence and terms. Test behavior at your boundary. Wrap it in your own controls. Input and output filtering, monitoring, oversight, and plan for the provider changing the model without notice. Back it up. Use provider evidence and strong contract terms. Test behavior at your boundary. Wrap it with filtering, monitoring, oversight, fallbacks. Plan for silent updates. Require change notice and retest. Say this: I can't control the model, so I manage the layers I can. Provider terms, my own wrapper controls, and a plan for when they change it under me. Monitoring, incident, and leadership. Questions 21-25. Question 21. A model's performance silently degrades in production. How do you catch it and respond? One line answer: you catch it with continuous monitoring of drift and performance against thresholds, and respond with a pre-built playbook. Alert, assess impact, contain via rollback or human review, root cause, and remediate. Back it up. Detect via input drift, output distributions, performance versus thresholds. The fact it was silent is itself the finding. Respond from a playbook. Root cause and remediate, then tighten monitoring. Say this: silent degradation means monitoring failed, so I run drift and performance monitoring against thresholds with a rollback playbook ready. Question 22. How do you build an AI incident response plan? One line answer: adapt classic incident response to AI. Define what counts as an AI incident, set detection and escalation paths, enable fast containment, rollback, kill switch, human takeover, then root cause, remediate, and run a post-incident review. Back it up. Define AI incidents: bias event, harmful output, drift breach, compromise. Set detection and escalation. Have containment ready. Run a post-incident review that feeds back into controls. Say this: I define what an AI incident even is. Build fast containment like rollback and human takeover, and close the loop with a post-incident review.